Hello everybody, thank you for being here. Today we're going to talk a bit about Monolith, a bit more about the front end and how it fits into the Monolith and how it doesn't fit into the Monolith, and where to go from the Monolith, and yeah, is the future bright and how to come there. And before I start, I should introduce myself. My name is Dušan, aka Develoger. I blog about the front end mainly. And you can find me on Twitter with this misspelled name of Develoger, and yeah, on my blog, which is the same, just domain essentials.com. Okay. So I work at the company which is called Smava. We are doing this online loan comparison solution. What does that mean? Instead of going to the old banks that are around filling these stupid forms, which usually have like 80 to 120 fields, you do the same thing on our website. So, and then we kind of aggregate the data from all over the bank world and present you some offers and guide you through this process of providing you the best offers. My role there is basically a front-end guy, and aside I'm also a TPO, and as a highly involved like front-end person on front-end architecture level, I work closely together with the DevOps on a daily basis, and thus I'm here today. So first, before we start, like how many of you actually, if you are nice enough to raise hands, how many of you actually still have this headache with a monolith in your day-to-day basis? Okay, that's quite a bit. I was curious because it's already 2018. It should not be like that, but still, I mean, somehow it is. And maybe in this like 5 years, we are gonna be out of that. So in order to talk about the monolith, we should first understand what it is. I mean, the problem with this picture is that there's like 10 monkeys and there's just like one monolith, and those 10 monkeys are trying to kind of comprehend it, to understand it, and basically to figure out what it is. I mean, if you didn't figure out, it's like from this movie called Space Odyssey. And even in the movie, you know, there is this situation when the monkeys doesn't have a clue, like what is this all about. And the time passed, luckily, and you know, the humans are not monkeys anymore. So now we have this better way of handling the stuff which was previously placed within the monolith from some outer space race, and it's called React. I mean, at least on the front end level. And when I say at least on the front end level, I can say that, you know, working with React, it means that you need to heavily rely on the backend services, and more precisely microservices, because it's like a client-rich single-page so-called application, aka library. So how many of you actually are using React in your companies? Okay, nice. So that already means like that there is some of you who are at least trying to get out the monolith on some level. I mean, I don't say that working with React necessarily means working outside of the monolith. Well, that's not necessarily true. Even the Facebook who invented the React, they're mostly embedded it into their pages. It's not like a standalone application or anything. So the whole point of monolith is it's not a single source of truth. You know, in programming you have this like concept of single source of truth, and it's quite good. I mean, but not if there is so much truth, and if it's and there is like millions of truths actually. And basically, monolith is just a pile of garbage most of the time. The problem with the pile of garbage is it's in nature that it's very easy to pile more garbage onto the pile of garbage, and it's very hard actually to clean it up and to find some how to say order in it. And especially if you want to remove something from it, it tends to break. If you want to add something, I mean, you usually just add something which doesn't add much value from the technology perspective. So what's the solution? Well, we can burn it, of course, but usually on the beginning that's not an option, especially not a good option. So we need to continue. So the first step should be something like the following. We need to try to figure out the separation of concerns within this single source of truth. And the most important point here is that this separation of concern on this level is actually not a technology thing. Because if you look at your monolith, and of course it consists of many like services. It consists of some front-end part, back-end part. Even within the monolith, you can still find like something which is kind of separated into the something which is grouped and work standalone. But the thing about the monolith is that you actually need to rethink your product. And before you start refactoring, you need to figure out, is this the way that you actually want to do the new kind of approach? Because most of the time, if you just have the structure which is working from, let's say, front-end perspective or even the back-end perspective, if you're just thinking like for the current structure and then you say, oh, I want to move it out to the microservice, or on the back-end perspective, or I want to move it into separated smaller front-end applications through the React or whatever. You can end up just having the same thing, especially in today's age, working on refactoring without having basically a reason to do it from the product level is, from the perspective of the company owners, always hard to accept. So, yeah, let's continue. So, step 2. Well, refactoring is actually a trap. And why is refactoring a trap? Well, like I said, in my previous experience, in many solutions that I saw, people just kind of tend to move one technology stack into another technology stack, and at the end they don't have much of a benefit. They basically, even though on the bottom level they still have a separated things that they deploy separately, that they can change separately, and the scope is smaller. But still, I mean, it's not only about the technology; it's also about the product. That's the whole point. And yeah, like I said. So there are a couple of concepts. How many of you just heard about or using this thing called PFF? Can you? Okay. I mean, it's good that there are some people, but it's even better there are not so many, because now you can learn something from today. And well, of course, the BFF means like best friend forever, but in our terminology, something different, and it's called backend for frontend. And in this scope, like backend for frontend is something which is really gonna benefit yourself and your team when you want to refactor your monolith into something more scalable, something with a smaller scope, and something which you can basically develop without being afraid that you're gonna deploy everything because of a small thing, and so on and so on. So before you actually consider how to pull your front end out of the monolith, you first need to understand like what kind of backend it requires, the current services enough to support it in a way, in the functional way, and most of the time, are you able to actually refactor everything, and then once it's done, basically kind of to replace the current stuff. But sadly, I mean, that's not the case. Most of the time you need to do this incremental refactor, and then you have the small wins, and it's good for the developers, for company management, for everybody, because they can immediately see some impact. Well, I'm first sorry for the quality of this. It's like my drawing on a whiteboard, and it should represent the simple use case of using the BFF. And in this case, I mean, I draw some horrible monolith, and within the monolith, what you have some service which does authentication, you have some service which returns the products and users. I mean, the point is that it's not like most of the time in these monoliths, what I saw is that it's not like what I say. I mean, like, it's not a single thing that is gonna always like render just like front end and is gonna do something on the back end. A lot of time actually there is these services which work separately, but they're still like in the monolith. And if you change out authentication, application, you need to deploy everything. That's the most horrible thing, actually. And then this monolith works most of the time in these use cases with some oldish schema of database. I mean, when you go to refactoring and you realize that you want to go from this row to that row, you will most probably actually going to challenge the structure in the database as well. So let's say that you have on the other end your React front-end application and that it's like delivered in a separate service. First, there is one challenge from the DevOps perspective is that now, most of the time this is just like Apache or Nginx or whatever, and then like all of a sudden you have a React application which is supposed to, if it's a decent application, if it runs with a server-side rendering, it requires a Node.js server for it. I mean, it requires Node.js. Even though you can run it, for example, there are some libraries that can embed Node.js within PHP or Java. I don't recommend it, it's horrible, but you can do it. How many of you actually, sorry, I lost myself. So, what happens? In this graph, in this picture, you can see that there is Monolith, there are some microservices which already works separately, and then you have like BFF, and then you have React. My question was actually, how many of you actually have running Node.js service in parallel with the Apache or whatever? And the people who are actually using React, do you use server-side rendering or it's client-side rendering? Okay, then you don't have this problem. I mean, the problem with not having the server-side rendering is really concerning because in this environment of the front end, I mean, if your application is not performant enough, your conversion rates are going to drop, and especially in the mobile devices, we are experiencing that all over again. Whenever you release something and it's not performant enough compared to previous thing, it's always going to show in the A/B tests that the mobile is not performing the same, and so on and so on, because the mobiles are very sensitive to the performance changes. So what do you do here? Sorry for a long introduction. You have these services, then you have like some microservices, and then what you have a BFF. Most of the time, this is a Node.js service, at least in our case, and in some cases it's also a Java service. It depends. I mean, the benefit of having it built with Node.js is that in that case the front-end team can maintain it, can develop it, and basically it's a back and forth front-end. And in that case, the front-end team should be the one who is responsible for it, and the front-end team should know how they get stuff and how they pass it to their application. And the most important thing, there are two important reasons why to go BFF. One thing is that in this case, the React application is a one service, and then the BFF is another service, and they're both public. That means that React application is going to communicate through the BFF to the monolith and the microservices. So maybe now you can ask yourself or think about it is it like a API gateway? I mean, yes, it is kind of API gateway on steroids. And what does it do? I mean, in most of the cases, because there are some services which are not ready to rewrite. And then there are some services which provide some data from like a microservice world. And then you have a front end. And front end requires data in a certain format with certain combination of information which you cannot get directly from this or directly from that. So what do you do? I mean, you do the list of few million evils, is that you don't do it, especially on the front end. I mean, there is this writing called no business logic. I mean, it should be like common sense, but funnily enough, it's not. When people started writing JavaScript, from 2009, for example, there was this introduction of JIT, which is called the just-in-time compiler, and it's actually a part of a browsers, especially the Chrome, where it's a part of V8 engine, where the good developers who developed it are trying to optimize the JavaScript in order for it to be run faster, because everybody knows JavaScript is a loosely typed language. It has types, but it's not like Java or anything, and it tries to analyze code. It tries to tell the browser after a few iterations, well, this information is integer, this information is like whatever, and then the browser, of course, is going to interpret the code faster, and that's why they say that the JavaScript is both interpreted and compiled language. That's like a tricky question for interviews. I mean, you're all DevOps, I guess, so I'm not going to face that, but it's interesting to know. So what do you do here? You combine this data on BFF, and your BFF knows about some business logic, and that's fine. And that's really fine. Sometimes you really will, like, just kind of proxy your microservice to it, but I mean, that's important to do because you don't want to expose publicly this part. Okay, by now we already figured it out. I mean, this is the game of Towers of Hanoi, if I pronounce it good, and you can imagine that the first photo on the top left is like a monolith, and then the goal is to put everything on the right, and obviously it's not a simple task. The thing is, like, if you go back, we can figure out that this incremental refactor of this front-end things is going to be coupled with some services, but then, I mean, believe me, it's like really, really challenging. So, step 3. This one is about the actual most important thing about talking the DevOps and continuous integration and monolith not being a thing and so on and so on. And it's called tasting. I mean, in this definition of tasting in the dictionary, you will find that they say like it's like trying something, figuring out what's the taste and so on and so on. And basically, the testing is the same. When you want to test something, you want to figure out how does it work, does it taste well, and is it going to break something or not. So I'm going to tell you one secret. Well, it's not kind of a secret, it's obvious. DevOps and the continuous integration world doesn't care about the front end, and that's the fact, and that should be most of the time like that. But what the continuous integration and DevOps care about is the outcome of the build. Is it passing or not? And if it's passing, of course, it's going to go to the production or the deployed and so on. If it's not, I mean, it's going to break, and then you'll have some kind of output, and then we can track down where did it broke and fix it and try to redeploy and so on, hopefully not on Friday. So in my culture, I come from Serbia, we say like this, I bet that it's the same of other cultures as well. But you need to measure something 3 times and then cut it once, And when you do it, you obviously on front end, you try kind of first to lint your code. Well, that's kind of a, touchy topic because when I first got introduced to linters, I was like maybe 23, very smart, and I said like, oh no, you're not gonna say to me like how I'm gonna write my code. I was like, very protective. And then like, funnily enough, a few years later, I was the one who somebody said that to again. And then I was like, oh, okay, things are getting better actually for me. And then you should run like the unit tests and hopefully end-to-end tests, and then you put stuff to production. And there are a couple of more things, but I just placed it because of the saying. So the first iteration of the testing actually should be done on a local machine, on the developer machine. And this is also a very tricky topic, and when you say something like that to developers, they most of the time say, oh, it's going to slow us down, or you're evil, and so on and so on. I mean, that's at least what I said back in the day. And, well, the thing is that you test the diff. I mean, we are all engineers or programmers or whatnot, we are smart enough, that we don't do horrible things, and somehow we actually always end up doing it on some level, especially with this stuff, and then people have this prejudice. So, on every commit, some people do it on the pre-push, but that also kind of, when you do it on the pre-push, then you lose the point. There are some commits which can be broken actually. So you try to keep your code really tidy and tested already on this level of commits. So the second iteration of testing, it's very like common, and it should be like some kind of common sense, it's introduced through the PR checkers. And well, on this level, on the any kind of repository level, on the Jenkins workflow or whatnot, in the background, you're gonna try to run these 3 kind of tests or any other set of tests once you have some feature branch or fix branch or whatever ready for like merge. And then of course, you know, you're not gonna allow that any broken code is gonna come to the point that it can come to the production. Well, now more about the details, more about this kind of testing. And how many of you actually heard about this term, like snapshot testing? Okay, so this is like a front-end thing, you know, and I mean, you know, front-end, it's very funny. It's a thing that you either are excited about or you think that it's overly complicated and horrible, and kind of broken. And well, the snapshot, what does it mean? You have your, let's say, React component or like Vue.js or whatever, but in our case, React. And you want to do a unit test, but then you have something which is called Jest. It's a library built for the JavaScript testing. And as a very quick win, what you can do, you can make a snapshot. What does it do? It can run your component in like a mock, and then it's gonna output what the React is gonna render. It can do it in HTML version, and it can do it in the JSON version. So at the end, you know, you have a snapshot. Most of the time, people actually do the HTML version of your component. And then it's kind of a comparison point. You run it the first time. If you're smart, you run it the first time in the way that it's broken, and then the next time you need to fix it. But if you use like the HTML version, you don't have any space for like detailed insights of what is broken if you break it and so on and so on. Luckily, there is a JSON version where you can have all this stuff which React is going to render, but in a more structured way. And if there is some problem, it's going to say like, you know, problem is exactly here. Because a snapshot, when it's broken, when you change something on the component level, it's always going to like, everything's going to be red, not just a thing which you need to encapsulate. So the snapshot testing means doing test-driven development from the wrong end. It means that you need to develop your component and then you're going to test it, which is, I mean, by nature broken. And if you want to fix something, most of the time people make a change and then there's, you know, the PR checker or the pre-commit hook say, like, oh, you know, the tests are failing, and what they do, they don't even check anything. They just like run these just update snapshots, and well, you know, everything is good because, you know, the new state replaced the old one, and of course that's prone to errors, and you know, it can lead to the horrible stuff because then you have a passing test, which is not necessarily good. And yeah, it's like it's good for a static content, and it's good for a first screen, but if you want to implement a real unit test, you need to take care about your method calls to basically really kind of consume your component or helper or whatever in a way that it should be consumed and not in the level that you're just kind of mounting the component and, you know, hoping that everything is gonna be good. So there is another thing, another part of this testing journey, and it's called end-to-end testing. Is there anybody who is like doing it in the company, or? Okay, just like a couple of guys. Well, thing is that end-to-end testing, well, yeah, it's always kind of a luxury. And here is the reason actually why you should do end-to-end testing, you know, because the development works like this and the production works like that. It's just funky. I mean, lots of times, you know, when you patch everything together, it's sort of an integration testing, you know. It's maybe the best way to do an integration testing through the end-to-end testing, I can say. And yeah, then you just kind of go up from the component level. You are not necessarily testing the backend services directly, but you're trying to, you know, make your application work as it should. And how it's done, basically, you can do it on many different approaches. One approach is to write it in a more front-end way from a JavaScript perspective, and use some headless Chrome in order to manipulate what it does. You basically say to it through the syntax, which is very close or is what we assume to be JavaScript, and even this look alike as a jQuery, for example. I mean, yeah, jQuery is a different story. And how many of you actually have this jQuery as a part of your code base still? Okay, yeah. Well, it's kind of a first love, I guess. So, where you should do end-to-end testing? There are basically ultimately two possible answers for this question. One is that you integrate it into your front-end application, and you integrate it in a way that you can run it together with the continuous integration workflow. What does that mean? I mean, if something cannot integrate well, when you start the test on the CI level, well, it's going to fail and it's going to say, yeah, of course, you know, the local pre-commit was good, and then the PR checker was good, but you know what? Something is wrong when you put it together and try to integrate, and you cannot deploy it. And the other thing is actually doing it separately. And in most companies, what I saw is actually it's like that. And then the DevOps actually do it. Some of you work with? Oh, sorry, it's the QA actually work. You know about Selenium WebDriver, maybe? Yeah. I mean, before the headless Chrome and stuff, you know, you were in the Puppeteer on JavaScript level, you were really kind of obligated to use the Selenium WebDriver. And I personally am not a Java guy, and I don't find it really great to work with it. And basically, you cannot embed it in a good way in the front-end level. And then it's running somewhere in an automated job outside of everything. It cannot scream or alarm when it's actually needed to do it. So, how about visual regression tests? This one is interesting. And what does it do? Well, when you do this end-to-end testing, if you go to your workflow, you basically tell to the browser, you know, open browser in the background, headless mode, open this page, you know, find this element, click on it, try to fill some form, submit it, and you know, during these tests, usually it's really good to do visual regression testing. What does it mean? You do a screenshot of a page and save it as a reference. Next time you go to a page, you use some kind of library, which is in JavaScript. There is this resemble.js, quite okay. I mean, it's the best of not great choices. And what does it do? It kind of tries to compare, you know, the snapshot in time, which is like the comparison point, the previous one, and the new one. And then it kind of produces some kind of output. And it says like, you know, there are some differences, and basically check it out. Can somebody maybe think about how this can be challenging because it's a front end? So that you have like screenshots that you need to compare, and then you need to take care about the details, which can be different. You know, it's the problem with the biggest problem with front end. Why people hate it? Somebody, yeah. So why people actually hate front end is because compared to the back end, where you have like one server, one environment, one language, you know, one device. On the front end, you have everything, and you can have like a million of devices. You can have a million different stuff. You can have the same browser on a different operating system, and it just have a different rendering engine. And basically, the font is going to be rendered differently, and there is going to be a falsely accused problem on the level of kind of comparing these snapshots. So how we tested it and how we did it. The problem is actually the execution of the test, and the problem is actually the updating the test. If you want to update test, you need to have the same environment. And in that case, well, today, luckily, and for some years now, we have Docker, and what we did there, we run our application within the Docker together with whatever is needed for the application. And when we do like continuous integration flow and we run this test in the Jenkins, we basically, you know, kind of use this Docker, run it. It always uses the same browser, it always uses the same environment, and it's basically just saying, you know, in this environment compared to the last time you ran it, it's good. It's not perfect, but comparing to not having it, it's quite okay. I mean, there are some solutions which a paid solution which you have a service that does this for you, and then they have all this like a layer of layers and layers of abstraction where they use a different browser, different operating system, and well, this kind of thing is anyway a luxury, and nobody wants to invest money in it, I guess. So, unified commit messages. How many of you actually like this idea and use it in a company? Well, not so much. Okay. I mean, most of the time when I mention this, people are like, like, you know, they're like, again, like with linting, they say like, it's not good. I mean, because if you put it like that, and you know, you should put this at the end, or you don't need this, you know, you don't need anything. Well, we're just gonna say like 10 times added linter, you know, in a 10 commits or whatever. We don't care. But what is the most important thing actually why we introduced this is the generation of automatic changelog. And what does it mean? In our workflow in my current company, when we need to release Monolith, there is this situation when we still kind of send an email, manual email. A person goes and say like, okay, with this release, those are the tickets that were being like introduced, those are the changes, and then push to some people like. So, you know, obviously when you have like 10 front-end applications and you have like who knows how many microservices, you cannot afford to do that. And in order to automate the generation of the changelog, you really need a standard. I mean, that's the only way. Without it, I really don't understand how you can do it. So in this case, like there are multiple like version of standard and standardization of the commit messages, and you know, we took this one, and what does it do? It has a type, it has a scope, it has a Jira ticket, and then it has some kind of description. Alternatively, or it can also include some information, more information, like more details in description. And also, is it a breaking change or not, which is really important. Okay, so this one is maybe quite interesting for you. Most of the time, the production environment is not the same as the testing environment in companies. And well, that kind of makes things complicated. And if you have a production environment, and if you're dealing with a monolith, yet it's most probably that you have like a single server or like 2 or 3 or 5 servers working like in kind of load balanced somehow. So we experienced this, and we are trying, we are like striving and moving through Docker-based production and Kubernetes and all this amazing stuff. But and it should happen soon. But at the moment, what we did is something called MVM. I mean, that's at least important for me as a front-end guy. And what does it mean? It's like Node version manager. We had a really hard issue because, you know, especially in the Node.js level, you should not be kind of limited with some using some old version of Node in your production, because all the JavaScript is actually module-based, like plugin-based or library-based, and those libraries really try hard to kind of, you know, move to new features, at least on the Node.js level, because, I mean, then it's a JavaScript. You don't care, it's like stage 0, stage 1, stage 2 or 3 proposal on the level of the syntax in JavaScript. You don't care about the compatibility issues that you face with the JavaScript within the front end on the browser level. So you can go crazy. I mean, you really should use async functions, for example. You should not use callbacks in most cases, and so on and so on. And in order to do so, I mean, you need flexible handling, at least, of the Node version manager. And what does it do? It's kind of an application which works on top of your like operating system, and it installs multiple versions of Node on your machine. And then what does it do? It does something really, really clever. On the level of your path, where your project is running in the application, it can change a path to the version, like system environment paths, to the version of Node.js which is going to be consumed on this specific path. So it's kind of very simple concept, but it's genius. Okay, this one is quite important, and it's also kind of a front-end thing. I mean, now you can see like this talk about moving out the monolith is actually talk about testing, and it's what kind of things you really need to take care about if you want to be sure that at the end of the day, when you're gonna release, you're sure that your new microservice, or in this case front-end application, will be error-free. So in the front-end ecosystem, you have these external libraries that you load on your page, which I'm sorry for the acronyms, but it stands for Google Tag Manager and VWO. VWO is like a visual website optimizer. And what they do, both of them are, the GTM is of course analytics thing, and it's a tracking thing, and basically you are sending some data to the Google Tag Manager, and then it sync the data with Google Analytics, so that it's kind of in an organized way put together. And Visual Website Optimizer, it's mostly used that you load both things on your page. With Visual Website Optimizer, you can literally do this A/B testing on the front-end level. What does that mean? You introduce some feature, and then you want to kind of gradually split a traffic. For example, like say 20% of the user to go to test the new feature which you developed kind of separately. You have a separate, most of the time, this versioning is done through the URL parameter. You say like, version whatever, and then you say to VWO, like send these kind of users to there. This is broken because, it's sending, what's happening is that on the level of front-end, once the page is loaded, VWO decides to redirect. I mean, you can see this kind of situation that it's doing an A/B testing, and in the same time, loading stuff on the front end, and then redirecting from the front end to another front end. It can lead to some false negatives, false positives, or whatever. So what actually people do with these things, especially with Google Tag Manager, because they want to kind of grab stuff on the page, and especially from the Google Tag Manager, you can put like a JavaScript script that is loaded with the page, and then you say when user clicks certain button, you send some data to the Google Tag Manager. Because people are free, I always say like people and developers, everybody is really free to do whatever they like, but they are not free to break stuff. And in this case, what is usually happening, especially once you come to the front end, separated front end like React or whatever, especially React, they're grabbing some element on the page, attaching an event listener to it, and then they are continue listening to the element, which most of the cases in some few clicks is not going to be there anymore. And then this event listener is still attached, it's not detached, and the browser in some cases can produce a memory leak, and basically your application can be broken. And then you went through the local test, you went to the PR test, to the continuous integration test, and then you're happy, everything runs in the production, but all of a sudden conversions drop, all of a sudden something is wrong and you don't know. And also what we had, very horrible situation that in this VWO thing, sometimes people change some, HTML from it, because they can. And of course, something needed to be changed, and then you change it in your application level, and then you deploy it. You test it locally, you test it whatever, everything works fine, and then bam, in production, there is no change. It's still the same. And why is that happening? Because on the VWO, there is some magic, and nobody knows about it, except the person who did it. So when you see that people working with GTM and VWO, just be very careful. So there is one thing in this pipeline of testing that can really help with moving from monolith to the separated environments is the performance testing. And this is the kind of the only one which I really recommend that it's not run together with the application. In our case, what we do, we run it daily. We run it in a way that it's done nightly when there is like a least impact and least users on our web app and so on and so on. Because we want just to have a good comparison point on a daily level. We really want just to, we don't need like, to analyze it, what can be better, because we tend to think that we know the front end, we should just, do this thing or and so on and so on. And also you can run this in a Chrome. I mean, if you go to the DevTools, you can run it locally. And you can kind of use your own comparison point. But what happened, for example, if you need to come from from the Monolith application, and you're like kind of pushing your React application into the production, in some cases, weirdly enough, in 2018, this React application by nature is slower and less performant than your Monolith app. Most of the time it's caused by a lack of server-side rendering, because of course, I mean, if you have like something rendered by Java or PHP or whatever, it's server-side rendered. It just works like that. And it's also funny how in this front-end thing is JavaScript, we started doing all this stuff and we thought that we are so cool, but actually what happened that when it began, we gone like 10 years back, because we didn't have server-side rendering, we didn't have like many of the things which are basically just shipped with the normal applications and so on and so on. And now it's kind of, the biggest actually impact was the component-based development. So, we're accepting, you say, okay, we are cool, we have a component base, we can move faster, we can, be reusable and so on and so on. So this thing actually runs in the background, it kind of, compares, and basically on the daily level you get the automatic reports, and then you can say like something got broken while we did the last release, or we introduced a good change, or something is wrong with server in some cases. So when we finally do all this kind of testing, and obviously the development before, we can just like, be very happy, we can deploy, and we can run all this stuff, and at the end, we can just burn the monolith. Yeah, that's it for today. So. Do you have some questions? I'm sorry if this was like too much of a front-end topic, but I hope that now I spent so much time working with our DevOps and many companies, and then I so much got insight into the DevOps side, and I'm very happy about it, even though I'm not happy about working DevOps job. So I hope that now we got like a better perspective on the front end, and you are still not happy to do the front end, but you know something about it. Hey.
In the migration process on discussed about how to migrate to microservices, how do you decide which component you decompose a monolith, right? What is the approach that you use to decompose?
Well, that's more of a backend question, but I can answer it to some extent. The thing is like, the first thing, if you talk about the front end, we are thinking on the product level. Like we really try to, kind of separate it on the product. I mean, we're kind of now almost 100% out of the monolith on the front end. On the back end, it's still not that much, but there is a lot of progress. And well, the thing is that sometimes it's really hard, even if you create a microservice. In some, maybe most, I don't have numbers, but in lots of cases, actually, you're still gonna consume sometime even like a monolith service in behind for some things, or you're gonna communicate with the old schema in database. So that's when I say this like Tower of Hanoi. It's a really complex thing, because you just cannot, you cannot refactor everything, or you cannot even refactor like the microservice fully without having some legacy in it in most cases. I'm not sure that I answered, so kind of. Yeah.
Do you split your front ends too? Or is your front end still a monolith?
Well, that's a really good question. I mean, how we do our front end, we really try to split it. There are also some decisions that are kind of questionable when you split it. You know, should be split or not. I mean, we've split it in like 6 or 7 applications basically in our funnel, and on addition, we are splitting it on the level of libraries. So, for example, we're now in the process of defining design system. What does that mean? We are kind of we created a style guide. We developed a library for UI DOM components, and then, you know, for React application, we build the UI with this reusable component library that we built. So, you know, it's all like that. We really try to kind of separate things per functionality, per the product, but then also to have these shared resources between them. And in some cases, we actually have this monorepo concept, where it really makes sense that some packages work together on the front-end level. But most of the time, actually, we have separated apps.
This means you have only one React app, or you have more than one React app?
We have quite a bit of React apps. Yes. I mean, you know, even if you do refactor, you still don't do it perfectly. I mean, that's the case most of the time, because it's like you're not only motivated by the refactor, you're also motivated by the change in the product or whatever. But to answer, yes, we have like at least 5, 6. It depends. I mean, when we need to launch, I mean, in Small we have just one product actually, but this product is separated into this user funnel and how it's, you know, logical parts. And then they work kind of separately, but they're connected in a way that we prefetch some resources for the next step and so on, so that user have this like smooth flow.
And does this mean that you store the state in local storage or something like that? Because if you have 2 React apps and you switch between them,
No. I mean, that directly is in a conflict with what I said as a no business logic on the front end. And yeah, we don't do it. I mean, we don't store any data on the front end, which is considered to be a business logic. What we do actually is that every application communicates with the backend services or microservices through its own BFF. So that these microservices and even the old stuff is kind of hidden from public. And that's the tricky part, because when you build that, you need really to think smart. In most of the cases, you build some microservice which is not flexible enough, and then you need to iterate it again, because you want new feature, and then all of a sudden it's not there. But to answer directly, we don't store any stuff in the local storage. We, yeah, it's like, there are some microservices are shared, and there is some stuff which is in the monolith, but yeah, we always get the data from the backend. But every application also has the application state, and it's about how React works. For example, you have like multiple components on the page, and they share the same data. You don't want to kind of this component to communicate between each other, and then you, in this session, you store the data in the application state, but it's different.
Is BFF just API gateway, or it orchestrates the services somehow heavyweight?
Yeah, I mean, it's not just the API gateway. It can be just proxying in some cases, but when you say it's a BFF, it assumes that it has some logic to it. Basically, most of the cases, what we do, we combine some data from the microservice and some data from the monolith. And then we put it in a data set and deliver it to the front end. So we do some kind of mapping and aggregation on that level, and that thing actually makes it a BFF. If we would just proxy, that would be API gateway, I guess.
But if it's BFF is down, then whose system is down?
Sorry?
If BFF is down, then whose system is down?
Yeah, of course. I mean, thing is like in most of the cases we decouple the BFF from the front-end application. That means that you can separately, you have two projects and you can separately redeploy them, which is very important. But in some cases when, I mean, we have just some simple logic and we all, really simple logic, and we know that it's not gonna scale or be changed, then we also put it in this service which works directly on the front-end application. I mean, it's not within the React code, it's kind of just on the same project. And then it still communicates with the microservices from there. But that's kind of a second choice if the first fail. Hopefully not.
Did you basically, I mean, as I understand, you're still like in migrating from a monolith to a truly or cloud-native application environment, basically, because you mentioned Kubernetes. Like, how do you spend currently, and how do you do configuration management?
Can you just say it a bit louder, please?
Sure. How do you do, for instance, configuration management with applications? So you said you don't really dockerize the applications.
Yeah.
But how do you scale? How do you do
Well, I mean, we heavily used Jenkins for this, and I mean, the thing is that it's actually a very good question because all the front-end apps are more than less require some kind of input on the build time, What does it mean? For some environment variables to whatever. I mean, in some cases you need to pass. What we have, for example, is that our Node.js services are always run on a subdirectory in the system. And then we have a reverse proxy configuration in the Apache that says, there's mapping this path to a Node.js service. The thing is that this public path, the React applications must be aware of it. When you build your system, assets and everything, the React application on certain points, it needs to know about it. So we pass this configuration within the Jenkins workflow and the builds, and yeah, I mean, it's working. What happens is at the end, after everything is like kind of passed the test, even though it's now still like a server environment, not Dockerized, we then like pack everything and then automatically copy it to the server, and then it's kind of extracted, and so it's automated. It's still automated. I mean, a person needs to kind of take care of it, but yeah. Okay.
Right. Thanks, Ben.
Thank you.